And now I would like to do the same again. Give Elsie Timms a warm welcome with a big applause.
I'm very excited to hear about DykSmart, which is a nice project. I was thinking of this is all about resource management and capabilities, knowledge. And I was going to take an example from another sea basin, from the Mediterranean. In the EU maritime strategy, it's obvious that you need to collaborate and between sectors and across borders and so on. So if you look at the Mediterranean in this current situation, you have counted 1,859 Coast Guard vessels. About 2/3 are capable of offshore operations. You have 321 helicopters capable of search and rescue. You have 103 maritime patrol aircraft capable of maritime surveillance operations. So, and then you think, is that why Iceland, Ireland, Sweden and Finland are sending vessels down to help with the migrant situation? Of course not, it's political, but there is a great work being done by the Mediterranean countries in organizing, recognizing what assets are available, at what readiness and how to use them for rescuing people in the Mediterranean Sea today. And then we rapidly move over to the Baltic with another capability, namely the diving capability, or you will expand on that. But it's a similar situation of a search and rescue assets in the Mediterranean as for you have done in the DykSmart project. I'm very much looking forward to hear about this. And think about you in the audience, what could be the continuation? What are the shortfalls? What should we do next?
Thank you, ladies and gentlemen, for sitting here. And I will be describing the DykSmart Baltic project. And the DykSmart Baltic project initiated from a national project called DykSmart. And in this project, we had some very valuable partners, and we also have some of them with us here now. We have the Swedish Armed Forces, Mr. Per Genvald and Mikael Ellsberg. And we have Mr. Richard Kloss, who is part of the DykSmart Baltic project, and Andrei from the Latvian Maritime Academy. And also somebody we have a lot of hope in the future, Mr. Oskar Frånberg is there, working at the Blekinge Institute of Technology. As Marcus says, there are a lot of resources, and when we started this project in 2012, we knew that there were lots of divers, lots of technical equipment, but that doesn't really matter if you don't have a plan how to use it and how to use it over time and how to sort of keep up an endurance over time if there is a big accident. The first question that you usually get in these circumstances is this project necessary? Is there any point? Are you going to save anybody's lives by doing this project? And we have a little YouTube clip, which I have now made sure works, and we will watch this for 1.5 minutes.
All right, so you should be walking on the ceiling, yeah? Okay. What's that?
This is off the Nigerian coast, and it is a small tugboat that has been attempting to help a larger container vessel who is in distress. And this tugboat has then overturned, and now the divers at 25 meters depth have gone into the tugboat to see if they can salvage any bodies. But it turns into a rescue action, because there is Harrison.
Drink it, buddy. Drink it. What's your name? Harrison. Okay, Harrison. My name is Colby. Okay, and I'm going to bring you home, okay? What is your rank? You're the cook. Okay, we survive. Put your head underwater and breathe comfortably, okay? Okay, how's that? Are you all right, Harrison? All right, stick his head in. Put his head in the bell. How are you in the bell, Harrison? Give me a thumbs up. Good job, my friend. Well done. You're a survivor.
And there's Harrison. And Harrison had then spent 3 days in that air pocket. So In that case, there is a point in this project. There is a possibility of saving lives. This is, of course, off the Nigerian coast. What we have to combat is the exposure, the cold. The Baltic is not a warm sea. Also, when you saw Harrison light up, then that is when actually light comes into this very closed compartment because it's pitch dark. And actually very amazing that he managed to survive. But it proves that there is hope and that you can save people after 3 days. And if you don't save them then they don't have a very bright future at all and a very nasty way of dying. So that's something that motivates me in this project a lot. The project has then been initiated from the Costa Concordia accident in 2012. During the national project, we noticed that there's some quite similar aspects drawn from the Costa Concordia. If you see the other, I'll see if I can use this little lamp maybe. No, I can't. Okay, well, you can see the houseboat. The houseboat was moored in the harbour of Malmö. And there was a big party, so there were 40 people dancing on the roof, and then all of a sudden it tipped. And it is exactly the same challenge to enter that houseboat as entering the Costa Concordia, so that the techniques that we are developing are hopefully possible to be able to be used in different environments. Now I'm going to quite quickly go through this presentation, try and keep my 20 minutes, and let you ask some questions. I might not be able to answer the questions, but in that case I will then point in the direction of the divers with the diving competence here. The DiveSmart project, which I will be starting with, is a national project, and why I will then linger slightly longer on the DiveSmart project is that it has great similarities to the DiveSmart project, the DiveSmart Baltic project that we are working on now. The DiveSmart project was a 4-year project. It ends this year, and the partners were the Swedish Coast Guard, the Swedish Armed Forces, and then we included during the process the national diving schools and realized that the regional rescue services have a vital function when going into rescue environments in sunken environment, and the police. The parts of the project that we've been working with is the mapping of resources, because if you need a diver, you have to have a diver with the correct competence. To be able to find the diver with the correct competence, you need to have them all listed. So we have listed all the divers, all the competences, and also all the technical equipment that is available in Sweden, so that if something happens and the big red button is pressed, we will be able to be there with the correct person and the correct machine. This has all gone into a database. We have focused on method development, which in brief I will describe in a little while, but exercises and the creation of a standard operational procedure. So if you do come to an accident site, you will know how to work together. National cooperation between participating organizations, mobilization strategies, development of exercise sites and routines, and then the focus of the national project was also to develop it into international cooperation. Looking at the mapping of resources, the human and technical resources, the focus was on very basic data: which organization, which location, how many divers, what competence, what equipment. If we then, as we have the answer, as the final report has just been published in Swedish, it will be available in English in a little while, we can then see that the regional rescue services, which are here called Räddningstjänsten, have the major amount of divers. Then the Swedish Armed Forces, then the Coast Guard, the police, and others. You can also see the red line, which shows the 24/7 availability of some of these divers, which is crucial if an accident does happen out of office hours. We can also see where these resources are situated. And having a look at this, when we looked at the national map, we could then see that there is a big gap around one of the major lakes. There is quite a big gap there. We then put it beside the map that was made in the BRISC project, where they looked onto the risk of collisions and saw that, well, maybe there aren't very many resources there. There aren't actually very many accidents, or there's sort of not a high risk of accidents. But down here, what do we have there? Oh, we have quite a lot. But it also depends on the availability of large vessels. If they are there, then you're lucky. So that was a good conclusion. The database is then built on the resources, and it also includes the need of training and education. And we have a challenge, and that is to keep the database, as I'm quite sure if you have invented databases in project, to keep it up to date. That's a big challenge. The person who actually develops a system to do this will have a brilliant future. Method development. The main tool here have been exercises, and that is to become familiar with each other's procedures and see possibilities in cooperation and find the gaps in preparedness. Because if you don't train together, then when you do come to an accident site, you will be flustered. You won't know really how to start, and you might spend time on trying to organize each other and yourselves to fit into a bigger scope. It's better that that scope and preparedness is in place in a standard operational procedure. When looking at the national project, we could see 3 phases. The first phase is from 0 to 4 hours. I won't go into detail in the various phases, but I will say that in that phase, the regional rescue services are very important. They'll be there quickly, they'll probably be first on site, and they will start the rescue work. Phase 2 is search and rescue. This is when one can see that the Coast Guard will be able to be mobilized there, and the Swedish Armed Forces will start to be able to be mobilized into that phase. And then phase 3, when 24 hours has passed, and this is when the Swedish Armed Forces will be in place, and when perhaps there is not a large chance of rescuing people alive, but that you are salvaging the people that are in this vessel and perhaps finding someone alive, depending on the environment that they are then trapped in. Why is the national cooperation important? Or why are the phases important? Knowing that there are phases also helps us see that we can develop competences that fit into these phases. Because if you almost always dive 0 to 10 meters, perhaps you don't have to focus on practicing down to 40 meters with the same regularity that you do to 10 meters. You can also find the correct equipment and deploy it quickly. The endurance is also an issue when studying large accidents, and especially the Seoul accident that was in Korea a couple of years ago. Then they had about 500 divers that came to the site and all started diving immediately because they wanted to help these people who were trapped in this ship. But then they have to stop diving at the same time. And if you don't have more people coming in, that's sort of a pointless way of working. You need a long-term strategy. Also an SOP for working on emergency site together. I emphasize the importance of that. Exercising sites and routines are important, and they are now in place. It doesn't cost very much. You just have to sort of focus on coordinating the exercises that you are going to do within your diving group and diving organization so that they sort of match together with the other organizations that could be deployed to the same accident site. And the conclusions after the DiveSmart Baltic project, and this is just relevant of Sweden, is no one knew which national diving resources were available 3 years ago. I will be perfectly honest and say we didn't actually know how many divers we had that were operational in the Swedish Coast Guard, but we know that today. It's now clear that we work more efficiently with training and also can in the future share expensive equipment, because we also have expensive equipment. We don't use it more than once or twice a year. That means that probably 360 days a year it's available for someone else with the qualifications to be able to use it. There are the 3 phases, which means that one can then look at specialization into the various phases. We do not have very good mobilization plans for a severe accident, but we are getting there slowly. There are some gaps in the national map, but not as bad as we initially thought. Cooperation is essential, and an SOP will help people when they come to an accident site to start working quickly, because in this very cold water, hours and minutes are very, very relevant. And the implementation of the project into the ordinary everyday work, that is the sort of boring side of it that we have to remember to keep up everything, is very, very important. Otherwise, the sort of good things that we have achieved in this project will then die. Now I'll go into the Dive Smart Baltic project. From a national project to an international project. And our main conclusion that we drew very, very quickly in the Dive Smart Baltic project was that no single nation can actually handle a Costa Concordia incident without assistance from other countries. And this is the partnership. I'll not dwell on that. And the work packages of Dive Smart Baltic are almost identical to the Dive Smart project, with the addition that there is a work package for research and development. And as you are at a technical conference, I will perhaps dwell on that a little bit longer. The database is more or less the same as in the Dive Smart Baltic or the Dive Smart project, that we'll construct it, we'll get the relevant data into place, then we'll be able to see where the gaps are, and then we will be able to look more specifically at exercises, the creation of an SOP, a mobilization plan. And the research and development is focusing on developing equipment that will be put into transportable modules. And this equipment varies, and I will probably leave the floor perhaps to the Naval Diving School in Karlskrona in a moment, but to get the best and most efficient equipment into these transportable modules, there is a lot of testing being done. We also have the involvement of researchers from both public and private enterprises. The project is a flagship project, but is also an interreg project, and that means that you are allowed to include private enterprises. So we have two. We have Cold Cut Systems and we have Ursuk. Ursuk makes diving suits and diving equipment, and Cold Cut is into how to penetrate sunken vessels with cutting techniques. You also can see the last point, the risk elimination due to modern equipment is very important so that you can protect the divers that are in the water. So in the research and development, what have we discussed so far? We've discussed battery packs, because if you do come into the submerged environment that Harrison was in, it's very, very dark, and one thing that will help people is if you put in light and you put in some kind of heat. If it's in a suit, or if you find some other ingenious way of bringing heat to these people who will be very, very cold, they will need energy, and the energy are in battery packs. Cutting and penetration techniques. It's difficult to cut into a partially submerged vessel, also in a submerged vessel, because if you do let out a lot of air, then you drown the people who possibly are alive in the sunken environment. So you have to penetrate with a well-thought system, and also with avoiding the harm of the people in the vessel. The use of explosives for penetration in emergency situations, so it's quick, and also other access by blasting. Side mount equipment, which is a way of moving the tubes. Mikael has explained this to me. Moving the tubes from your back to your side, so you get even slimmer than usual, and then you can get into quite tight areas. The design of transportable modules. We also have AUVs, ROVs, and sonars. Detection equipment for contaminated water. And these are all areas that we hope to look into in the coming 2 years and possibly improve. We won't be able to do everything by ourselves. We will need help with that. So that's a sort of question, free question. Looking at the second last point, the AUVs and the ROVs, we have another large project within the Swedish Coast Guard, which is a feasibility study to find a common AUV that can be used by different organizations, different national organizations in Sweden. So I think that the AUV sphere will be quite interesting and will be developing quite quickly, maybe even the crossover models. And that's what I would like to say. I will emphasize also with a little quote. Coming together is a beginning, keeping together is progress, and working together is success. And that sounds so easy, doesn't it? And everyone who's worked in an international project here knows that it's not that easy, but we are trying to get there. So, thank you.
Very
now,
good.
I'm quite
Thanks
available for questions.
Good.
Yes.
Any questions?
Yes.
Please use this.
Well, I'm Harry Robertson from Stena. I was involved in some educational efforts after, I think it was after the Herald of Free Enterprise. And there was teams put together at that stage to learn more about shipping and ships arrangements. I couldn't see that in your presentation.
Do you mean specific rescue teams? Sort of
Well,
like
it was a group
teams?
of divers, so they know what to expect when they come into.
There are
the
two
vessel.
initiatives that have been suggested. The DiveSmart, or the Dive, yes, the National DiveSmart report has various suggestions, and I've only briefly sort of gone through some of them. But one suggestion is that we have said that it would be a good idea to establish a council, a diving council, a national diving council with the major stakeholders within professional diving and also the diving schools, and also to be able to pick out maybe 40 divers, give them extra exercises, training opportunities, let them get to know the sort of newest equipment that is available, and that they will be on call. That sounds very easy, and it's always a question of getting things coordinated and financing and so on. But the council that we have established will deal with this issue when it progresses with its work, I hope.
Well, thank you for a very excellent presentation of a very, very good project.
Thank you.
Yeah.
Could you please elaborate about those transportable units? Are they supposed to have decompression chambers?
Yes, because decompression chambers are, of course, very important. Because our friend Harrison, if he had been rescued at 25 meters, would, of course, have died if you had taken him to the surface immediately. So the capacity of transportable pressure chambers is very important. Exactly how these modules will be equipped is difficult to say right now, because we're sort of testing equipment and seeing, is this something that can go into the modules. A module, also, you will all think, as I'm showing it like this, is a square container, but it is not just a square container, it is the people around the container. That is a module, or when we describe it in the project, a module is both the technical resources and the human capacity that goes very, very quickly to an accident site. And possibly there will be a transportable pressure chamber there, because it's necessary.
Okay.
Okay.
Marcus?
Just a few words on. Thank you for your presentation. It was very interesting. And,
Thank you, Marcus.
My experience from Coast Guard functions development is that there is a Coast Guard Academy network being set up at the moment with a Finnish lead, with participating Coast Guard functionalities from all over Europe, including military. Diving courses. This is all about training and certification of divers or diving people. So my question was that has there been any contacts between this European Coast Guard Functions Academy network, between DiveSmart and this Academy network so far?
Well, I suppose that our former colleague and friend Don Torell is probably involved in this, and he was also responsible for the DiveSmart Baltic project when working at the Coast Guard in his previous function. So hopefully if it does arise, then there will be a possibility of getting information from him, because he is well informed about the project.
Okay, then I have an idea also.
Okay.
To keep the database of qualified divers updated, let's give them 100 euros per year to report to the database.
Oh,
if they don't they won't get any money.
That's too much money. Sorry, I'm hard there. That's too much money. No, we would not put in, not those sums of money at all, because we have tried to see. I mean, a diving project like this is not actually very expensive. What we have money for now is that, I mean, the national project only cost 3,100 euros. That was just a person who sort of enthusiastic people and divers and made them sort of start to work together. You need the correct person. Otherwise, I mean, now we can test some equipment and buy some equipment, so we have, of course, a little bit more money, but it's not something that costs a lot of money. So I'm sorry, the 100 euros is ruled out. Yep.
Okay, let's make it 50 then.
Okay. That's a
One
bargain.
last question.
Sorry, Jonas.
Very short question. Is there any role in this for recreational divers and recreational diving organizations?
Not so far. At the moment, we're focusing on professional divers. The possible development would be that we would go to professional employed divers in private companies, because they are usually quite good at construction diving. The recreational divers will, in that case, be the sort of third point. Are you interested? A little bit. I will give the opportunity for Per to say something if you would like to fill in something, Per or Mikael, as they are our closest cooperative partners.
As the commander of the Naval Warfare Center, that is a part of the National Diving School, we have also gained a lot of challenges of cooperation and working together between two different authorities. And as probably many of you know, that many times it's in the processes that the challenges are. And this project has really went very well forward, because it's a very good aim. Also, everybody can see the beneficiary of the project. So everybody involved has been very positive and going forward and so on. So I think that's enough.
Thank you.
Hello, Michael Elsberg from the Swedish Navy Diving School. We have taken up most of the subject regarding this, but if there's some question, technical or whatever, that you want from a diver point of view, just ask me during this afternoon or tonight. I can relate to what Elsa said. One thing is to get the diver inside. We can do that, but that's just 1/3 of the problem. The thing is, we have to get the people out, and we cannot take them out, so we have to keep them alive inside the ship until we've got some way of transporting them into a pressure chamber. So that's a really hard task to perform. So it's not just getting there; it's just keeping them alive long enough to get them under decompression. Yep, thank you.
I'm quite sure that you would all be very patient if you were in a black hole with water slowly coming in, wouldn't you? So I think the challenge is also the people. Okay.
Thank you very much, Elsie. You also get a small appreciation gift from us. Thank you for an excellent presentation. And they are trying to imagine how it feels to be stuck in that hole, and then all of a sudden something light comes up underneath, and you think that, this might turn out to be a good day anyhow.